We'll be dealing with the chapters of the rotatory motion and the gravitation. So these chapters will be seeing most of the questions. So let us see one of the question, conservation of the momentum and all these things, please. So gravitation, conservation of the momentum, rotational mechanics. These chapters will be dealing with these things. So coming to the first question, a gun of the mass m is there. It fires a shell of the mass m. Okay, from the gun. A shell is fired horizontally. The energy of the explosion is such as you find a sufficient to project the shell vertically to a height h. The recoil velocity of the gun is going to be how much he is asking. So what is the recoil velocity of the gun? So since gun firing and the shell case, both of them are an, no external force has been involved. So we can go for the law of conservation of the momentum. So before that one, let us consider one thing. So let V2 be the recoil velocity of the gun. Recoil velocity of gun. So if I consider this one as a V2, then V1 will be obviously it is for the veloc shell. Okay, so this is our relationship, please. Now, next, if I go for the apply the law of conservation of the momentum in this relationship. So P initial has to be equal to the P final, but P initial before firing is equal to 0. That is before firing. So before firing initial 0. So after firing, if we go, since already it has been mentioned as a recoil, so that is small m into V1 minus capital M into V2, since both of them are going to be moving in opposite direction, I've taken a negative sign. So from this one, velocity of the shell V1 is equal to capital M into V2 by small m condition. Okay, so this is the velocity of the first one. Now, what he has goes specified in the question is energy of the explosion is sufficient for the project for it to project the shell vertically upwards to a height called as an h. So now, if we go for the energy, so that means I'm writing the same information. So energy of explosion. Energy of explosion is equal to, so which one is equal to the kinetic energy of system. So if it is equal to the kinetic energy of the system, then let E be the energy of the explosion. Kinetic energy of the system is half m v1 square small m into half capital M into v2 square. This can be written as an half small m into. From here, if I can substitute, the v1 is equal to mv2 by this is capital M into velocity of the gun by small m whole square plus this can be written as an half capital M into this is v2 square. Now solve this particular thing. If I take common as an or v2 square, so this can be written as an capital M into. So here next one of the m will be cancelled. So small m plus capital M into this is going to be the v2 square by 2 into small m. This is your energy of the explosion. But with the same energy, E, it is reaching to the height h. It is reaching to height h. So since it is reaching to the height h, that means the same energy should also be equal to the mgh, but the same E is equal to the m into small m plus capital M into v2 square by 2 into m. So from this one, he has asked the velocity of the gun, which is nothing but our v2. So take down everything to the other side. So v2 square can be written as an it is 2 m square gh divided by capital M into small m plus capital M, or from this relation V2 is equal to the 2m square GH by capital M into this is small m plus capital M of whole to the power of 1 by 2. So this is our relationship, please. So this comes out to be the which option? 2m square GH by capital M plus small m whole to the power of 1 by 2. So this should be our option A. Next one. Coming to the second question, a string is wrapped around a cylinder of mass capital M and the radius is R. The string is pulled vertical upwards to prevent the center of mass falling as the cylinder unwinds. The string tension in the string he is asking. Okay, let this be our cylinder. I'm drawing the side view of the cylinder like this. This is your center of mass. Obviously, mg is going to be acting downward sense here. So like this, there is a string here acting in the upward direction. So tension in the string will be in this direction. The radius is going to be the R. So since it is executing the translatory motion as well as the rotatory motion, since it is executing the translatory motion and as well as the rotatory motion. So for the first equations of the translatory motion, so translatory motion, so if I write this one, so downward force is going to be the mg and upward force is going to be the tension, but the same thing is going to be coming down with a velocity of, so it has been coming down with an acceleration of a. Let us imagine it is coming with an acceleration of the a. So within a, so mg will be greater than tension. This is going to be the ma. So let me write it as an equation number one. Now for the rotation, torque is being produced by the tension, that is torque is equal to general formula I'm writing force into perpendicular distance. Tension is being acting for the torque. This is I into alpha. So moment of inertia of the cylinder, which is rotating about the axis, can be written as n. P into R is equal to mr square by 2 into alpha. But we know that the linear axis, since it is under the rolling, that is A, can be written as an R alpha. So from this relationship, alpha is equal to, this is A by R. So replace in the this tension relationship, please, which is tension into radius R is equal to mr square by 2 of. So this can be written as an A by R. Now if we can remove the R on either sides, from this relation tension can be written as n. This is MA by 2. So substitute in equation 1 the, so what is our equation 1? Mg minus T is equal to Ma. So that will be equal to the, this is Mg minus T is equal to Ma. Substitute the tension here. Only one mass is there, that is the mass of the cylinder. Ma by 2 is equal to, this is also Ma. From this one, Mg is equal to 3 Ma by 2. Or acceleration is equal to 2g by 3. He is asking the tension, substitute in the tension. T is equal to ma by 2, which is equal to the m by 2 into acceleration is 2g by 3. That comes out to be the mg by 3. So this is our final answer. It is going to be the mg by 3. That will be the option 3. Next case, please. Two satellites A and B of the same masses are there revolving around the Earth in a concentric circular orbits. They are moving in a concentric circular orbits such that the distance of the satellite B from the center of the Earth is thrice as compared to the distance of the satellite of the A. That means what is the information he has given, sir, here? That is the radius of the B is equal to 3 times the radius of the A. This is the one he has given. Then the ratio of centripetal force acting on the B. Then the ratio of centripetal force acting on the B he is asking. So since they are being moving in an orbit, F can be written as and this is G into capital M into small m by that is the gravitational force is there and that should be equal to your centripetal force. So from this one F is proportional to the 1 by R square. From this you can write it as an force on the A or the centripetal force on the A by B is equal to radius of the B by radius of the A whole to the power of, you can put it as an square, right? So now if I substitute the radius of the B, it's going to be the 3 by 1 whole square, and that will be equal to the 9 by 1. Okay, so or it is FB by FA is will be equal to the 1 is to 9. So this should be our relationship, sir. Next question, please. Two identical semicircular discs of mass m, each of radius r, are placed in the XY horizontal plane and YZ plane. So suppose if I draw this one, this is our x-axis. So let me take this as our y-axis and let this be our z-axis. So two discs are there actually. So this is our z-axis in this case, please. Now two discs are there here. So which are in the first disk is in an XY plane. That means it should be like this. And your second disk is in the YZ plane. That means it might be like this. It should be in this way. So same radius, both are having the common center in this way. So common diameter is along the y-axis. So this is the common diameter for both of them along the y-axis I've drawn. The moment of inertia of the system he is asking. So if I go for the moment of inertia along the x-axis, according to the options, we'll go. So first one, I'll go with respect to the x-axis. So if I write with respect to the x-axis, let this be the first disk and let this be your second disk. So coming to the first disk, the x-axis is passing through the diameter. So the moment of inertia of the disk passing through the diameter should be equal to the mr square by 4. And the same axis is going to be the perpendicular to the second disk and passing through the center. Then it should be the mr square by 2. Then the summation of these two things will be the 3mr square by 2. So this is your moment of inertia along the x-axis. Now if I write for the second one, that is with respect to y-axis. So if I write with respect to the y-axis, so for the first one, it is passing through the diameter, moment of inertia along the y-axis. For the first disk, y-axis is passing through the diameter, so it should be the mr square by 4 plus. For the second disk also, y-axis is passing through the diameter. It is also mr square by 4. So that it will be the mr square by 2. So this is your Iy is equal to mr square by 2. So I can go for the second option now. Next case, moment of inertia that is with respect to the z-axis if I write it. So when I observe the z-axis, for the first disk, z-axis is passing through the center and perpendicular to the plane. That means it has to be the mr square by 2. And for the second disk, z-axis is passing through the diameter. So it should be the mr square by 4. So in the sense, it should be the 3mr square by 2. So this is the z value. And it is clear and evident that your Ix is equal to the Iz, which is equal to the 3mr square by 2. Now, when you look at the option, so Iz is 2 and this one is also 2. So this is the wrong option. So your answer will be it's a multiple answer question. So B is correct, C is correct, and the D is correct. B, C, D. Next one. A particle of mass m is thrown into a parabolic path towards Earth having a mass. Earth mass is m and the radius is r. Particle small m is thrown in a parabolic path towards the Earth. It comes to an greatest approach distance of r by 2 from the surface. So it is just coming to the greatest approach distance of this particular thing r by 2 from the surface. The magnitude of the total energy. So it is coming to certain distance where it's going to be the r by 2. So what should be going for this one now? The particle is moving in an elliptical path. So if it is it's a gravitational constant and eccentricity he has. So greatest approach point either the perihelion is asking or the perihelion. So either of them he is asking. So eccentricity value E is equal to 1 by 2. So if I go for the case of this one, that is our eccentricity relation with an, if I suppose if I draw an elliptical relationship, elliptical like this. So now this distance is called as an, this is called as a minor axis and this is called as a major axis. Let this distance is going to be the B and this is major axis, semi-major axis will be the A. So what is the, it comes to a greatest approach distance r by 2 from the surface of the earth. So this can be your r by 2 conditions, that is B value if I take it as an. So B he has given it as an already distance from the center is going to be the r and it is coming to a height of r by 2. Then it will be the 3r by 2 B value he has provided. So since B value he has provided to us, we can find the A value, that is the semi-major axis. What is the relation between both of them is eccentricity E is equal to root over A square minus B square by A square, or if I substitute E value is equal to 1 by 2 is equal to, or else put it under the root 1 minus B square by A square. Now squaring it on either sides, please. So when I square it on either sides, it will be the 1 by 4 is equal to 1 minus B square by A square. So take them to the other side. From this one, B square by A square should be equal to the 3 by 4. So if B square by A square is equal to 3 by 4, now substitute the value of this one. Or your A square is equal to 4B square by 3, which is equal to the 4 by 3 into. What is the B value that we have got here? 3 by 3r by 2. So it will be the 9r square by 4. 9r square by 4 it will be. So then 4 goes off and this will be the 3. From this relation you can write the A value as an, that is root 3 times of the r. So how does this particular thing is going to be working out? It is the closest distance for the perihelion and the ephelion distances to find out the velocity at the perihelion and to find out the distances at the ephelion. We can find out this values will be more useful for us. So at a distance of A is equal to root 3r. So at this particular distance, if I try to find out the velocity at that particular point, so or else if I apply the law of conservation of energy, that is from law of conservation of energy, if I apply in this case, so in the initial case, that is a half m into velocity on the surface of the earth is going to be the v square or v naught square on the surface of the earth minus g capital M into small m by r is equal to, this is half m velocity at the ephelion. So I'm going for an ephelion. So this is the one which is going to be written over there, ephelion point I'm writing. So for this situation, if I write this, half m v square of this will be the, how much at a distance of, this is 2g capital M into small m by 3r, because the b distance is 3r by 2 I'm writing here. Now for this case, if we solve this one, this is going to be the half m. V is Q can be written as an on the surface of the earth gm by r minus g capital M into small m by r, which is equal to the half m v square of minus 2g capital M into small m by 3r. Now when you solve for this one, this is going to be the half and this is 1 minus half you'll be getting on solving this one. Half m velocity at the epihelion. You will be getting it as an g into capital M into small m by 3r, or from this relation, if I remove this one, velocity at the epihelion is going to be the root over g into this will be the capital M into small m by, sorry, small m has been removed, it will be the 3r. Now, he is asking in the question, what is the change in energy? Total energy change he is asking at the epihelion and the perihelion. Now, if I write for n, that is delta E, which is change in energy, is equal to. So, on the surface of the earth, you can write it as an this is going to be the half small m into velocity we have got, final velocity gm by 3r. And whereas the initial velocity before the projectile is being thrown, it will be the 4g capital M by 3r velocity whole square. On solving this one, you should be getting it as an minus half g capital M into small m by r. So this is the change in energy at epihelion, that is 1 by 2 into gm by r. Another one, same thing for perihelion if I write it. For perihelion, you will be getting on solving the velocity like this as a root over. It is going to be the gm by r only. Now for the change in energy, if you can put it as a half into mass into this is final kinetic energy minus initial kinetic energy half into 4gm by 3r. You should be getting it as an 3 6 is there, so minus 1 by 6 into g capital M into small m by r. So these should be the changes in the energies for the case piece. So only one thing is going to be the valid in these type of the questions. You need to write the law of conservation of necessary angular momentum. This is the one you need to write. Law of conservation of the energy you have to write. These are the two statements sufficient for solving the sums in the gravitation most of the things. Next one, question number 6. A uniform disk of mass m 1 kg is there and a radius of 20 centimeters is rolling. So it's under the pure rolling because on the surface its center is C. Okay, the acceleration is going to be the 20 meter per second square. Velocity also he has given center of mass velocities. At a certain instant, A is this particular point and B are located on the disk as shown in the figure. A is equal to B is equal to 10 centimeters. He is asking the kinetic energy of the disk. Okay, since it is under the pure rolling, so for the rolling, kinetic energy is of the two types. One is a translational kinetic energy plus another one is kinetic energy of the rotation. What is the relation for the translation kinetic energy? Half m v square plus rotational kinetic energy is half I omega square. Now velocity he has given, we don't know the omega, but since it is under the pure rolling, v is equal to radius into omega. Velocity is 4 and radius is going to be how much, sir? Here he has given it as a 20 centimeters, 20 into 10 to the power of minus 2 centimeters into omega. So omega can be calculated as 400 by it is 20. So that should be equal to the 20 radians per second. So we have got the omega. Or else you can do in another way also, substitute the corresponding values, sir. Half it. Instead of finding the omega, you can write the common value. That also I'll show you. So half m into mass is 1 kg and velocity is 4 square plus half moment of inertia. Also, I'll just calculate here. Moment of inertia of the disk is going to be the mr square by 2. That can be written as an mass is equal to 120 into 10 to the power of minus 2 whole square by 2 it is, which is going to be the 1 by 2 into 4 into 10 to the power of minus 2. These two things you can remove. This is 2 into 10 to the power of minus 2. So moment of inertia 2 into 10 to the power of minus 2 omega square. 20 square, that will be equal to the 400. So if I can remove these two things, so this is going to be the 16 by 2 8 plus this will be the 4. So your total kinetic energy is 12 joules. Or else you can also do this in this array. This is kinetic energy is equal to same relation. It is Ke of the translation plus kinetic energy of the rotation. Or this can be written as an half m v square plus half I. Same thing. Omega will be written as an v square by r square. Moment of inertia can be written as an m k square. K is the radius of the gyration. So if I take the common as an half mv square, I can substitute in this one 1 plus this is k square by r square. So radius of gyration for a disk will be the r by root 2. So if I substitute here half into mass is 1 he has given I suppose 4 into 1 minus r's 1 plus r square by this will be the 2r square. So r square cancels, it will be the half into 16 into this will be the 3 by 2, or these two things will be 4 for 3 it will be 12 joules. You'll be getting the same answer, no problem. Next one. Okay, it's the same disk, continuation sum is there, fine. So that means it should be the passage condition. A uniform disk of the mass 1 kg and the radius is equal to 20 centimeters is rolling purely. Okay, every values are same. He is asking acceleration of the unit. So please listen carefully here. So in any pure rolling condition, the acceleration at any point in a rolling object, it will have the three accelerations. So first acceleration is going to be the acceleration of center of mass will be there, that he has given it as an A, which is equal to the 20 meter per second square. Second one, radial acceleration. So this is along the I direction. I'm taking on the vectors also. Radial acceleration or centripetal acceleration, that is AR is equal to R omega square. For this one, radial acceleration is also in the this is also in the along the x-axis direction, sir. So since it is along the x-axis direction, this is AR radial acceleration is also towards the center. Radial means, so this is R omega square. I'll just write it. R value is going to be 20 centimeters. 20 into 10 to the power of minus 2 into omega square is 400. So these two zeros, this will be cancelled, and this is going to be the 80. Okay, so this is the one of the things R omega square. And the distance of the A we need to write, sorry. So since we have got the omega square, so A radius I need to put it down. So A radius is only 10 centimeters. So that means here it should be the 1. So then the distance it can be the which is equal to the 40 meter per second square. It is equal to the 40 meter per second square. Next, what type of the things will be there? The third type of the acceleration that will be there for the pure rolling is an tangential acceleration. Tangential acceleration formula at is equal to r alpha. So tangential acceleration will be in which direction? This is the direction of your tangential acceleration at. This is your direction of the acceleration of the center of mass. So at is in the upward direction. If I consider this to be the x-axis and this to be the y-axis, and this is along the I cap. Okay, so now tangential acceleration, we need the r alpha, but we don't know the alpha. So alpha is equal to acceleration of the center of mass by total radius r. Acceleration of the center of mass 20 he has given. This is 20 into 10 to the power of minus 2. So these two will goes off over here and this is going to be the 100. Now if I solve for the tangential acceleration is equal to R value is going to be 10 centimeters. At the A he has asked to 10 into 10 to the power of minus 2 into alpha is 100. So that value is equal to it is 10, but it is directed along the y-axis, it is 10j. Then if I write the net acceleration vectorially, this is acceleration of the center of mass plus acceleration of the radial plus tangential acceleration, all of them. Acceleration of the center of mass, we have got the 20i, it is 20i cap plus radial acceleration, we have got it as an 40i, this is 40i cap plus tangential acceleration is 10j cap. So this is 60i cap plus 10j cap. So the magnitude of the acceleration of the A, mod A net acceleration is equal to root over, it is 60 square plus 10 square. So that should be equal to the root over 3600 plus 100. That is root over 3700. If I take it outside the 10 only, so this will be, you can write it as a 10 root 37 meter per second square or adjust it according to the options over there. 10 root 37, this is your option B. So next question, please. A ball is moving vertically downwards with a speed of 10 meter per second, collides with a platform. The platform moves with a velocity of 5 meter per second in the downward direction. Okay, so it is colliding with the platform, but platform is also moving in the downward direction with 5 meter per second. So when you compare, if I take the mass of the ball as an m coming in the downward direction with 10 meter per second. So this is your platform of mass m2. This is your platform of mass m2. This is also moving in the downward direction with 5 meter per second. This is initial. Okay, so coefficient of restitution, find the speed of the ball just after the collision. So both of them are moving in the downward direction only. So initially, so in this case, you can consider that M2 is going to be the very greater than M1. Platform mass is going to be the heavy mass when compared to the mass of the ball. So then coefficient of restitution also he has given. If I go through the coefficient of restitution, let the initial velocity u1 of the ball is equal to 10 meter per second and u2 is equal to 5 meter per second. After collision, since it's a heavy mass, velocity of the ball after collision will also be, platform will also be same, it will not change. So in that sense, if I go, E is equal to, it will be the V2 minus V1 by, this is relative velocity of separation after collision, by relative velocity of the approach before collision. So if I try to write in this one, V2 will be 5 minus V1 by U1 values, U1 is equal to 10 minus U2 is also equal to the 5 and this value is going to be the 0.8. Now if I cross multiply 0.8 into This is your V1. That is the V1 is velocity of the ball after collision. This is for the platform, sir. So 0.5 into 5 is equal to 5 minus V1. So that should be equal to the 4 minus 5 is equal to minus V1, or your V1 is equal to 1 meter per second. So this will be the case. So yeah, initially I have considered that platform is also moving with a speed of 5 meter per second. There is an ambiguity in this question. This is 10 meter per second collides with the platform. He has not made here. There is a full stop is there. So platform is moving with a 5 meter per second downwards. He has mentioned, but there is no information whether this is before or after. So if it is before only, this will be the case. So this is only for before conditions. Whether if it is an after case, then we have to consider that u1, that is the initial velocity of the ball, is equal to 10 meter per second. u2, that is the platform is at the 0. Then v2, he has given it as an 5 meter per second. We need to find out the v1. In that situation, E is equal to v2 minus v1 by u1 minus u2. That is 0.8 is equal to 5 minus v1 by u1 is going to be the 10. So u2 anyway 0 from this one. It will be the 8 is equal to 5 minus v1. So from this one, v1 should be equal to the minus 3 meter per second. So if the platform is moving after collision, or if the platform is moving after collision, so this will be the working load. Okay. So in either case, you just go for this one. The value of the acceleration due to gravity at the surface of the Earth is 9.8 meter per second square. He has given the acceleration due to gravity on the surface of the Earth. G is equal to 9.8 meter per second square. And its radius is going to be the mean radius. He has asked us to take 6.4 into 10 to the power of 6 meters. Assuming that we could get more soil from somewhere, okay, some other, it is not unnecessary where he is getting the soil, that's not necessary for us. He's getting the soil. Estimate how thick. So he's pouring that soil on the earth. He's adding them. Added uniformly on the outer layer of the earth to have the value of the acceleration due to gravity as 10. So he wants to change the acceleration due to gravity from 9.8 to 10 meter per second square. For that one, how much layer, how much thick layer we need to apply it on the earth, he is asking. Suppose this is our initial radius of the earth. On this one, if he is applying certain layer and he is pouring the soil, so that the radius is been increasing by some distance called as an. So let me name it as an some r dash. So this is the entire thing he is pouring onto that one. Okay, now this is the thickness of the soil. Thickness of soil on the earth. So he is asking that particular thickness. So what is that thickness is? R dash minus R is the thickness of the soil we need to base. So now from this relationship, G value is equal to the G capital M by R square general formula. Since the as we add soil, what will happen? Mass will also change. Mass will also change. So this is a basic thing that we need to remember. So and density is given the density of the soil, earth soil is going to be the constant. So then we have to convert this as an G by R square into mass can be written as an volume into density, which is 4 by 3 pi r cube into density r square and r cube if we can remove. So this will be the 4 by 3 pi g rho into r. So in this situation, all these terms are constants. So that means G is going to be dependent only upon the R. In that situation, G dash by G should be equal to the new value R dash by R. So from this relationship, I need the value of R dash. R dash is equal to G dash by G into R. What is the new value of the acceleration due to gravity? He wants it 10. Earlier value is 9.8. Initial radius is 6.4 into 10 to the power of 6 meters. Now, when you solve this particular thing, so how much it should be, sir? 98 by 100. So this should be roughly equal to the 1 point. So that means, or else 100 by 98 also, if we can take it, that is 2 is left over. 20, if I take it as an roughly, it should be the 1.0 something else. 0, 2 like that we need to go. Okay, so I'm multiplying this particular thing 6.4 into, I'm just going for an approximation. Let me take it as in some 6.5. Okay, into 10 to the power of 6 meters it should be coming. I'm just taking a round and around or 6.54 like that. 55 anything. Just I'm taking an approximation value here. So this is the new value. Then the thickness is equal to R dash minus R. That is equal to the 6.54 into 10 to the power of 6 minus, that is 6.4 into 10 to the power of 6. That comes out to be the 0.04, so 0.14 into 10 to the power of 6 meters, or the same thing if I mention it in the because he has asked in the kilometers. Exactly, he has asked in kilometers. So that will be nearly equal to the 140 kilometers. You will be getting the correct answer if you do this calculation exactly. So this is the one how we need to solve. So this is around 140 kilometers is there. Okay, this is an integer type of the question. And next one is a matching case. So coming to the matching condition, there are the two men are there who is 60 kgs and another one is of an 80 kgs. On a plank of mass, 20 kgs is there. So plank mass is 20 kgs. Okay, so this is your 20 kgs plank. Both of them can jump with a velocity of 1 meter per second relative to the plank. In each event, okay, first one, if man one jumps alone, okay, if I go for that one, so initial momentum is how much, so no external force is there. Initial momentum P initial is equal to 0 and that has to be equal to the P final. So when he is going to be jumping, first case I'm solving A. What is the final momentum here? When he is going to jump with 1, then this will be moving in a backward direction. The plank is going to move in backward direction with a velocity of the 1 meter per second. He is jumping with 1 meter per second relative to the plank. Who is jumping? Man 1. Man 1 is 60 kgs. So that means P final should be equal to the 60 into, or else shall we write this one m1 into the relative velocity of the man with this with respect to the 1 plus v, and who is moving now in the other direction, 80 kgs man plus plank, or else let me write this one in terms of the m1s and m2s only first case. So this will be equal to the mass of the second man plus mass of the plank, both will be moving in the opposite direction with the velocity of the v. So now if I substitute the values here, that is m1 into 1 plus v is equal to minus of m2 plus mass of the plank into v. So this is 60 into velocity of this one 1 plus v is equal to minus of 80 plus Planck velocity. I suppose he has given it as a 20. So that is going to be the 20 into velocity v. Now expand this one. 60 plus 60v is equal to minus of 100v. From this relationship, v is equal to minus of 60 by 160, which is equal to the minus 3 by 8 meter per second. This is your velocity if first person is going to be jumped. Until that means one is related to C. I have got this one. So one is C is only in the first option. You can directly go for the solution. But let's deal for the B also. What is your second case is? If only second man is going to jump. Same information, if going to second man is going to be jumping, then I have to write it as an m2 into 1 plus v is equal to minus of m1 plus mass of the plank into moving with the velocity of the v. So if we solve this one, 80 into 1 plus v is equal to minus of 60 plus mass of the plank 20 into velocity. So when you solve this one, both will be getting, sir, 80 plus 80v is equal to minus 80v. So from this one, v is equal to minus of 80 by 160. That will be equal to the minus 1 by 2 meter per second. So this is A. For the A I am solving. Next for the B I have solved. B is minus 1 by 2. That means 2 should be matched with B. So we have got this one and we have got this one. Next, if you feel that both the masses are been jumping, what is the question C? If one jumps towards the left side and two jumps towards the right side simultaneously. So initial momentum anyway 0. If one is jumping towards the left side and two is jumping towards the right side, then what it should be, sir? 80 into man 2 m2 into 1 plus v. Right side taking positive, left side taking negative, minus 1 plus v plus 20v should be equal to the 0. So this is expanding on this one. So this will be 80 plus 80v minus 60 plus 60v plus 20v should be equal to 0. So now if I solve this one, it will be the 80 plus 60, 140. This is going to be the 160v is equal to, that will be minus 20. From this relation, v should be equal to the minus 1 by 8 meter per second. So that will be your option D. So third should be related to the option D here. Obviously, if he is going to be jumping, this will be the reverse order. That comes out to be your reverse case, last case. This will be your 17 by minus 17 by 40 you should be getting. Or else I'll write here for the D here. Both of them will be moving. Man, after first, since the first M1 has jumped, so still M2 is on the plank. Then 80 plus 20 of the plank is moving with a velocity of how much when first is going to jump? He'll be getting the 3 by 8 velocity is equal to latter if he jumps 1 plus v plus 20v. Now you can solve this one. You should be getting, obviously the only leftover answer is minus 17 by 40 meter per second. So your B should be your right option. So